So hi everyone, welcome to our weekly session of VODAN Africa and Asia. So my name is Alia and today we're going to have a look on the list of topics which is presented on the the slide. So just a quick question. Professor Francesca, are you going to lead this session?
Alia, can I just welcome some people?
Oh, yeah, sure.
Thanks a lot. I wanted to first of all commend all the groups and everybody for a lot of work that has been done in the last week, and we have really made a lot of progress. So congratulations to everybody. I see everybody, almost everybody is here, which is really good because today we are reaching the kind of the deadline that we set ourselves for the preparations. And Professor Francesca is going to lead us through this. Before we start, I wanted to really thank everybody for being here, and so that together we can finalize this phase and move ourselves into the next phase of implementation. So big thank you, first of all, to everybody for participation and also all the work that has been done. And then I would also like to welcome Les and Luke from data biology. If you want, don't hesitate to put on your camera. They will be giving a presentation today in the session, and we've had some very excellent preparatory meetings with them, and Dr. Sakinath has agreed from our group to lead, to be the contact person with them. So we are grateful for that as well. So I don't know, Les, would you like to say something at this point?
So, yeah, Miriam, many thanks. I'm traveling in my car, so I hope the background noise is not too bad. But yeah, it's a pleasure to join the group, and we look forward to contributing to the MVP over the coming 3 or 4 months.
Wonderful and excellent, Les, and big welcome to you and the team. So the overall preparation for today is that we are going through all the preparations which have as a deadline today. Professor Francesca is going to lead on that, and then we have left the last half hour to the presentation of data biology, which then really projects us into the future, and that will be led by Dr. Sakinath and myself. So I would like to ask all the presenters to remain short because we are covering a lot of ground today, but of course all of this has been prepared in the technical working groups. So it's really here to, with the objective to report and to make sure that we are all on the same page in the different technical groups. So with that, let me hand over back to you, Alia, and to Francesca. Thank you all.
Right, thank you, Professor Miriam, and I would like to add my voice to yours to welcome Les and Luke from Data Biology, our newest and the latest partners, and to, I think Louise just entered the room as well from Data Biology. We're really happy and excited to host you today during our webinar, and we'll be happy to hear from you, me and every member of the community. Like has been said, we will first take updates from the different technical groups very briefly because we already discussed it at a different fora, so it's not an issue. Alia, if you can help with admitting people so that I don't go on. I tried, yes, there are people in the waiting room. The first update today will be from Samson and Getu on the architecture. Samson, if you're ready, Alia, could you please make Samson a co-host so he can share his screen, or if they're using Getu's screen, so that we get an update on the work on the architecture by the our technical team on architecture. Samson?
Yes, Prof, can you hear me?
Yes, yes. Thank you.
Can you see my screen?
Right.
Good afternoon, everyone. Can you hear me?
Yes.
Okay, thank you very much. Before I start, I would like to convey a message from Dr. Araya. He said he couldn't join because of contesting issues, and he said he's sorry. With that, I will go to the presentation. I'll try to quickly present a requirement specification that has been done on the architecture. I think as most of you've already seen the architecture and its components, what we tried to do is we tried to add as technical specification as to what has to be done in each of the components of the architecture. For instance, in the first section, it is input or bulk input. In this one, there are a couple of things that has to be done in relation to the different data sources that it has, because we have a lot of data sources from paper-based sources to sources from other systems. This component is a component that does the bulk upload of data from different sources. Here are the requirements. I think we'll share the document and everyone can follow into the details. And in the interest of time, I'll try to go to the next component. The next component, we call it one-stop data editor. This one-stop data editor is a component which helps the data stewards to insert data once, and the data goes to the DHIS system. The data goes to the analytics dashboards. The data goes in the form of fair data point to other data sources as well. So this one is an objective that we want to achieve, basically, because we want clinical data to be stored only once, and the requirements R7 up to R14 are functionalities that helps us do those things, like ability to collect data, ability to send it to the HIS2, ability to send it to triple store, and ability to export data, and the likes are the features of this one-stop data editor. And this one-stop data editor is going to be the initial viable product that we're thinking about installing in each of the clinics. And in relation to this, we've also been working with CEDAR technical team with the support of John, and we were able to install locally the editor, but we are working on further features. The other one is the VODAN residence host, and the other component is, as you can see, the clinics need to not only insert data, but they should be able to get feedback from the data that has been entered, and they should be able to see dashboards in the clinics. So they will be able to get feedback. That's one value proposition that we are proposing to the in the architecture. We also have in-residence data output dashboard. This is the dashboard that's going to display the data for the data stewards inside the clinic, and it's presented here. And we are going to have the VODAN residence host, which is going to be act like an FTP or fair data point, where remote queries can be done. And the requirements 17 up to 19 are aligned in that sense. And what we're thinking is we think that all the tools need to be bundled into one system that is easy to install with the help of Docker or virtual systems. That is going to help us because we don't want technical hurdles to stop people from using the system, and we think that the installation process should be easy. These are, I think, working modalities on how we should be implementing them. Overall, this is what has been done. Over to you, Alia, and thank you very much.
Right, thank you very much, Samson, for the updates. Like we said, the technical teams already looked at that, so it's for the at-large community. If there are questions, we can take them after the last presentation by data biology. I would like to welcome Dr. Kebede from Liberia, JFK Hospital. He joined while Samson's presentation was going on. Dr. Kebede, if you can just turn on your camera and say a few words of just let us, yes, we'd like to welcome you to the VODAN Africa meeting for today, and thank you for joining us. Yes, doctor. All right. We'll take the next speaker. We'll receive the updates on the access and control for the hospital questionnaires by the team of Putu. Putu, if you're ready, would like to take your updates, especially from your meeting of yesterday on the hospital's questionnaires. Alia, can you make Putu? Yes, Putu is already a co-host. Right.
Yes. Thank you, Professor Francisca. So yesterday we discussed about we practiced the how to do interview, and then we have some input from the members of access and control, like how we should cover. We should add the question of how long the interview will take place, and also we should not record the interview. And based on that input, I create tools for interviewing the health facilities, and I will share my screen. Actually, I made this document. I will share the link in the chat box, and I put all of the health facilities interview tools here. For example, like the invitation letter, so and then the information letter, consent, questionnaire, and introduction transcript, and also the GDPR rules, PPT, and theory of planned behavior. So this is only the direction of the interview. So the leader of the group in each country can adapt these tools. For example, like if you want to put any information in questionnaire, so for example, like this questionnaire. So if you feel that there is a question that can be added in this questionnaire, so you can add some questions about that. And basically, I made this question based on two topics. First, to identify GDPR rules. So that's why I provide PPT here. It's about the GDPR rules explanation, short explanation. So basically, I made the question based on that. And I separate the question for director, manager, supervisor, and also and the next questionnaire is basically that's the same question but different tone. So the director is different tone with the staff of the health facilities. I mean, like directors knows the computers, like how many computers in the health facility, but staff didn't know about that, I guess. So that's why I split the questionnaire into two, and basically the question is about identify the GDPR rules, and the next topic of the question is about theory of planned behavior. It means like how's the intention of healthcare worker to do data management. So that's why I also make a notes about that in the question. So for example, like this. So I put it's based on theory planned behavior. So I also make a researcher note here. So question 3 and until 4, it's about the ability to work with a data management system. So it's about perform a given behavior. So, and I also put theory of planned behavior here. So the leader of the group can read the theory of planned behavior before check the questionnaire. So that's my update from access and control, Professor Francisca. So basically, I will share the link of the document that provide all of the questionnaire tools to make a questionnaire based on the context of the country.
Thank you very much, Kutu, for your report. And if there are questions we can still take in, or the country teams, we can always liaise with Kutu in person. If there are things we find not so clear, we will be happy to provide that. We'll take the next update from the team of templates, Miriam and Aliyah, based on your meetings on Mondays and the other sub-team meetings. We'd like to receive updates from you.
I guess Mariam can start first because they create templates, and then I'll continue.
Okay, so I'll give an update on the template creation for the different countries. So with the Ugandan team, we selected the OPD register, and the template has been created already. And then with team Ethiopia, there's still some issues with the selection, but we decided to work with the OPD register as well with Getu. And then for the Nigeria team, there's still some issues identifying the right record to digitize, because most of the outpatient records have actually been digitized within the hospitals. So the data is basically then entered into an HMIS form, which collects aggregate data. So we're actually looking into verifying the HMIS form, but it collects the aggregate data, which contradicts the original agreements. Maybe I could share my screen to show the templates for a few seconds. Okay. Sorry. So these are the elements for the templates, as you can see, and then this is the template itself. So this is the institution metadata elements within the templates. So it collects the name of the facility, the code, the level, the countries, the sub-county or division, and the HSD, the district, the date open, and the date close. So for all the health facilities in Uganda that use the DHIS2, whereby all the facilities use the DHIS2, have the collect this data, the metadata about the institution. So, and then it goes on, and yeah. So this is it for the Ugandan templates. And then with the Ethiopian template, I think Getu should be able to share his screen.
Mariam, could you also very briefly show how you create the idea for JSON machine readable language? Since we have some guests, I think it will make more sense to see that it's not just a form, but that it creates machine readable language.
Should I, well, this is the machine readable language at the bottom. It's in JSON. So yeah, and so basically when you create the templates, it automatically creates the JSON schema for you, and then you're able to copy paste this schema and use it for whatever purposes you want to. So as you can see, we the order of the pages is here. We have the institution metadata element, and then the name of the health facility, the month, the financial year, the serial number, the NIN, the name, the age, all the different property levels are included as well, along with the descriptions. This is the metadata for the different fields. And then I also included some help text. So within the within the form, I should have the form here. So within the form, this is the kind of like the metadata, but in paper. So what I did for that, I used that as the help text for the template.
That's good.
So, yeah. So on clicking on the question, you're able to find information about the different fields and what is required to be entered. And then, so after this, the next stage is to select the different vocabulary terms for the different fields, yeah, which are still in the process of being verified. So, and Aliyah will take you through that part. So yeah, I think I can stop sharing my screen now. Thank you.
Great.
So thank you, Mariam. I think I can continue. So our team and the Dr. Sakinat's team are working on vocabulary creation for those templates. So actually we identify the terms that needs to be created for these templates, and then create them and do them create them in machine readable format and upload them in bioportal, which can be pulled in templates and can be used in hospitals and facilities. And as Mariam's team identified the terms that needs to be created, like the controlled vocabularies, they identified the terms. And then we have started uploading the terms to bioportal. So we have uploaded a few terms, and then it takes some time, and we are working closely with John, who is helping us to troubleshoot the issues that we face at this point. So, but basically it's going well, and I think in 1 or 2 days we finish the terms for the outpatient register for Uganda, and then we'll start working on the other template. So creating other vocabularies. So that's basically it.
Thank you very much, Alia, for that presentation. Since we have that of G2 for Ethiopia, perhaps we'll have to do that the next meeting so that we can leave enough time for data biology. We intend to stay within the hour. I will quickly give an update on the clinics since there has been meetings anyway within the team, so it's nothing new. But then because it is required as part of our meetings every Tuesday to receive updates from different groups. So for the clinics and health facilities, we have the complete 20 clinics identified for Ethiopia, and we have actually received we have actually started the process of the team identification for the hospitals, and we have agreed on the modus operandi, which will be specific for that country. We have also received the OPD, that's the outpatient data, and then the maternal child health registers for Ethiopia, and that is currently being, the templates are currently being built, and then the vocabularies that are not in the bio portal will be created by the team of Aliyah. In Nigeria, we have 5 clinics. Nigeria is actually very big and then diverse, so we are probably going to have a lot of work in that country because it's hard to have uniformity even across local governments and state lines, and there are 36 states in the country. So we're expecting 20 health facilities from Nigeria. So far, we have 5 that are confirmed. Others have been contacted, and we're waiting to get their nod to list them as part of the project. For Uganda, we have 3 confirmed clinics. The Vice Chancellor, who is also the chair of the implementation network, informed me earlier today that he was going to send in 2 more names in addition, so we can say we have 5 for Uganda so far. Thanks to Dr. Jamal, we have 20 clinics in Somalia that are already signed up, and we have the list ready, and the letter for that country as well is being finalized as we speak. So far in Kenya, there are 2 hospitals. I'm happy to welcome Dr. Geoffrey Mutuma from the Zambezi Hospital in Kenya. His presence here actually signifies some high degree of interest and a very high level of success that we have made. We're happy to have you, Dr. Mutuma, and then we hope that with you, we have things very easy in that country. In Tanzania, with the help of Dr. Jeremiah, we're going to be working in 1 hospital. We'll be happy to do more, but for now we have 1 confirmed. And the same for Liberia. We have Dr. Kebede here from Liberia from the JFK Hospital. His presence here also signifies the level of success we have made in the contact and networking for Liberia. And for Zimbabwe, well, of course, we have the Great Zimbabwe University Clinic, and then there is other additional clinics that we're expecting to finalize with in that country. And Professor Bernard is here leading the team. Budakwashi and Godin are unable to be here, but we thank the member of the VODAN Africa board, Professor Bernard, who is also here at this meeting. So those are the updates. I will continue to update via emails. We have the list of clinics, and we have been able to identify and group them, whether they're tertiary clinics or they're provincial or district or state-based or federal-based clinics. So far we have that. And the letters have been passed by the chair of the board, Dr. Mpesa, the VC of KIU. He has signed off on the letters. So we're going to be sending them out based on the access and control and specified by G2 in the meeting of yesterday. So each country team will know what additional things to do on the letters, who to give them to, and then what additional information. The team of Obina is working on an information card that will accompany each of the letters. So on a page, at a glance, each of the administrators can actually have an idea of what is expected of them. That is all from me on the updates from the clinics. Now I would like to invite Dr. Sakinat to introduce and welcome data biology on behalf of the VODAN Africa project family. Dr. Sakinat. Let me see if I can find Dr. Sakinat. Otherwise, I will request Professor Miriam to kindly stand in for
I
Dr.
think
Sakinat.
she's not in the
Yes, she has been having issues with her network. If Professor Miriam will be happy to step in, please. Thank you, Prof. And apologies for.
Thank you. That is a very amazing list of achievements, and really so proud to you, but also all of our technical leads. Really fantastic job. Very nice to welcome our three. We used to have the 3 Erics, but now we are adding to that 3 Miriams, 3 Erics, and now we have the 3 Ls of Les, Luke, and Louis from data biology. And we welcome you, and I am sure that everybody is excited. We have been speaking about you here. So everybody will be very excited to see what you will present to us today. Les, please, the floor is yours.
Yes, thanks, Miriam. So, Luke, if I can hand over to you to do the presentation, that'd be appreciated.
Absolutely. Let me just share my screen whilst I'm doing that. Here we go. Let's minimize that. Excellent. Okay, thank you, everyone. Thank you very much for your kind welcome. Very excited to be part of the team and to be involved. What I'll run through is a series of slides that hopefully tries to explain a little bit about what data biology does, where we fit in all of this, and what data biology does. And then happy to take any and all questions. So let me start with a bit of simplification. On the slide I've got here, I've put a very simplified arrangement of how we saw, at least initially, by default, everything fitting together and where we come in. So I've got 2 clinics listed here, just for the sake of example. And then connected to those 2 clinics, we have the fair data hosts. These are the sort of upstream sources of truth for the data. And then linked to those below, we've got these 2 repositories, repository 1, repository 2, for clinics 1 and 2. So in my next slides, I'm going to try and simplify this a little bit by including the fair data hosts with each clinic, so you can think of them as sort of one and the same as I go through. So if you're wondering where they disappear, that's what I'm doing. I'm kind of showing this all from a very high level. So if I can encourage PowerPoint to move on to my next slide. Here we go. So how does data biology come in? What does data biology do? So data biology's role is first to connect to any upstream data sources. So in this case, there's fair data sources. And the idea is that we register but don't transport any of the bulk data. So the idea is all the data exists in its home, its original location, but then we index data that you need for search, so that you can query the data, find your cohorts of interest, explore it, approach it from different directions. And one crucial thing I should mention is data biology as a piece of software is completely agnostic to what the data looks like. You know, it doesn't matter if there's multiple file types, whether it's imaging, sequencing data, clinical records, phenotypic data, doesn't matter at all. The point is we just want to connect to those upstream sources so that you can then query it, you can visualize the data, get a dashboard over it, access the data and put it to good use. So then how did we see this working with VODAN? So I think the default option is the simplest, my first diagram up at the top left there. So I think the default is quite simple, that each clinic would end up in this virtual environment with a project, something we call a project in data biology. It's basically a virtual environment where you have your data, and crucially, each clinic would by default only be able to see their data. So clinic 1 sees clinic 1's project and their data. Clinic 2 sees their data in another project. So there wouldn't be a, there wouldn't be a, at least by default, any sharing of the data. So there'd be a secure access limited to that clinic's data. Let me move on now. If there is desire for this, a clinic can have multiple projects. So there's no limit to the number of projects that a clinic can have. You might have multiple different data types that you want to separate out into these different projects. There isn't any functional limit. It's just by default, we think it makes sense to have one clinic to one project. And there's also the possibility of sharing data. So in my second diagram here, what happens if Clinic 2 has 2 projects, projects 2 and 3, but they're interested in sharing that data with the first clinic or the wider community. So this is something that can certainly be done. What they would do is they'd share the data that they were interested in, or the subset of data that they were interested in sharing. And so if we look at this diagram from the point of view of Clinic 1, they would then see, first of all, their clinic's data in project 1, their own project that they have complete control over. And they'd also see the data that Clinic 2 had shared. So their world will expand a little with the data that had been shared, and they'd be able to search over both. So a little bit of a recap of all of that very briefly. So by default, we had imagined each clinic having their own virtual project or projects. Data biology is connecting to these data, not transporting it to some kind of centralized location, but merely indexing data for search and connecting to any bulk or file-based data in case that's going to be used in analysis as well. Just so the system knows where that data is, and so it can be used by the clinic in their own project workspaces. Important to note that by default, the access to the data would of course be limited to members of the clinic to see their own data, but there's plenty of possibilities for sharing with everyone or specific people, specific organizations. That can all be done very easily. So getting ready for analytics. This is the second part of what data biology does as a piece of software. So not only is the point of data biology to index the data so you can search across it, query it and find cohorts of interest, but it also does orchestration of analysis. So that's why we need to know where those data are, so that when you say, I want to run, let's say, a variance analysis pipeline, the system can orchestrate that for you. So to do this, or to be able to orchestrate that analysis, we see that clinics need a few things on top of their data. So of course, data is number one. Number two is compute. If there's going to be some analysis done on the data, there needs to be some compute where that's going to take place. So much like the data, compute can be virtually added to data biology, just sort of registered. And then Clinic 1 would be able to run analysis on their compute in their virtual project. And then each clinic will also need one other thing, a results storage. So this is where, if I stick with my example of a variance analysis pipeline, if you run that, you're going to get some results at the end of this, and you're going to want to save them somewhere. So this results storage is just a storage location that each clinic can nominate to say, this is where I want my results from my data to go when they run analysis. I also included in the yellow box here an option for cloud compute, very similar to the data, and the storage is data biology is completely agnostic to what compute you want to use. It doesn't matter if it's on premise somewhere, a computer somewhere in a lab, or if it's a cloud service provider. Anything, including the big cloud providers like AWS and Microsoft's Azure, all agnostic to those as well. So the idea is that you can use any data and any cloud, any compute when you're running this. So there we go. Another quick recap. So DB can connect to any storage and any compute, and it does this in a virtual way, similar to the way it connects to the data. Then each clinic would have their own compute, their own nominated results storage, and that's sort of the default position, the same as with those projects. Everyone would have their own compute, their own results storage. But of course, if there are possibilities for communal options, cloud compute that's shared between clinics, let's say, that's all easily done. And the results storage is also clearly important from a sort of data governance point of view. You want to make sure that, as well as making sure that only the right people can use the data, so making sure that a clinic can use their data and no one else can by default. We also want to make sure that those results go to the right place, the clinic's chosen location. So I wanted to put this into a little bit of context without turning this into a data biology demo, but to give everyone a feel for what this sort of looks like in practice and what are the steps in using data biology. I've taken clinic 1 here, so they've got some data, they've got a result storage where they want analysis results to go, and they've got compute. So where do they start? Well, they start in search, and this is where they will see over their entire data portfolio and any data that's been shared with them. So being able to query the data, query clinical data, phenotypical data, also genetic data if they have gene symbols, whatever it might be really. Like I say, agnostic to what the data looks like, but being able to quickly and easily query that data and get a sense of what distributions there might be in the data, for example, but then also ultimately find a cohort of interest, a selection of data for analysis. The next steps, having found some data that you want to use, is to pick a tool that you want to use. In data biology, we simply call those applications, and we're agnostic yet again to what applications anyone wants to use, be that a script, program, web app, complete pipeline, interactive command line, that doesn't matter. So the way this works is that I, as a user, I sign in, I have access to my projects, I go to search where I find my cohort of interest, and I select that data. I then can click a button called Application Suggestions in Data Biology, and that looks at the library of tools that are either generally available in data biology or that I've added my scripts and my pipelines to the system. And it compares which tools, which apps will work with my data that I've selected, and gives me a selection that I can pick from. I then pick my app, whatever that might be, my chosen tool for my particular analysis. And we create something called a work unit. And this is where that storage and the compute come in. Very simply, a work unit just records who did what, when. So Luke did variance analysis using Luke's variance analysis pipeline, or perhaps on another day I might be using an application, let's say a data science notebook like Jupyter. But I record, I give my work unit a name, check that it's going to run in my project. I then select the storage where any results are going to be saved, and I pick something called a submitter, which is basically just picking the compute that I'm going to run on this. So you see in my screenshots, I've got a couple from when I create a work unit, and on the right image here, this was me selecting a submitter, so the compute, and I happen to have a few options there, including a couple of cloud options from Google Cloud and Microsoft Azure, but also a data biology compute machine that we have as well. So then data biology basically does the data wrangling there. So one of the things that... Hi, Les.
Can I just interject? I'm just conscious of the time, so if you keep it somewhat brief to the time contact.
Sure, yeah. Just a couple more slides. So basically, the system then sets up the analysis in whatever tool that might be. So I mentioned a variety of different tools. Some will be interactive, some will be lights out pipelines that run and return results. One of the things that Data Biology does is provides the data that you've selected, that cohort, in the machine readable format, so that you can then take it and use it in any tool, whether that's, like I say, something interactive, or if it's going to be something that runs automatically. And it's also very helpful because it does this on the basis of the application, so it only provides the relevant data. You know, if you're running an imaging analysis, you don't want to provide the sequencing data, for example. And two final slides. One, I just wanted to explain the sort of where does the data go in all of this? Is it going to, where is it being transported to? That kind of question. So the simple answer is the data for, let's say, Clinic 1's data goes to the compute during analysis, and then any results that are created, they go straight to the results storage. So the data doesn't ever go to some centralized data biology location. The point is it goes to the clinic's chosen compute and then results to the clinic's results storage, where the results then exist alongside the original data with all the provenance that comes with having recorded this through a word unit. So you get the provenance and you also get the enrichment, the results, the insights are fed back into the original data. And then, of course, these results also appear and can be searched in our virtual project as well, that the clinic has access to. This last slide I'll just finish on was a sort of a high-level view of how we saw this planning out with all of the clinics. I think it was 52 so far, each with their own virtual project, each able to run search over their data, look through it, find cohorts of interest, and run whatever analysis is most relevant to them to get best access to and best use out of their own data. So I'll finish up there. Of course, if anyone has any questions, or Miriam, Les, if either of you want to add anything to what I've just run through.
Yeah, thank you very much. Look, I'm taking over from Professor Francesca, who's leading the procession in her university. She just sent me a picture and she was looking magnificent. So good luck, Francesca. Look, very, very interesting. I want to first of all ask our friends from Data Science Nigeria to respond, maybe just to make sure that everybody understands where we are in all this. We have, of course, our own data science biology and our own groups working on the access and control issues, PUTU, and on the data dashboards, Yilin and Getu and Samson. In addition to Data Science Nigeria. What we so far have discussed is that data biology will work with 3 volunteering hospitals or facilities. If they would be available, we expect yes. And of course, the principles of what we are doing are like our holy grail. So that is number 1, the data remain in the clinic. The data ownership is with the clinic. The data ownership has full control over the data access and control, and within the regulatory framework as provided in the country, in the context. Our objective is to ensure that the digital data really contribute to the options for providing quality of care within the clinics. And only after all that, there can be the possibility of sharing data across for very particular purposes that we will have to, first of all agree. And secondly, each facility, each health facility has to also agree. So there is a complete stoplight with red and green, and the data ownership is real and complete and absolute. So I just wanted that to be very clear, that that is our starting point and that everybody has that comfort. But it would be nice to hear from Data Science Nigeria a response, or from anyone else, Getu, Samson, anybody. From Ibu, who can I give the floor for a response? Abdullahi?
Hello?
Yes, please, Abdullahi, please go ahead.
Okay. I think it's fine. It's interesting. Some of what I'm seeing data biology present, as well as our journey so far. It's a long one, and it's only reassuring that we're making very important progresses. I'll just add that there are a few points that came across in some of our most recent discussions, and this is part of the working groups that have been part of the template localization group led by Miriam, as well as I think when Samson made a presentation, I did have some feedback. I'm not sure if this is the forum to discuss some of those, but I do think that there's some information we need to consider, looking at now what now happens within this.
Yeah.
Yes. Sorry, can you hear me? Yeah, so reflecting on the Holy Grail that you just highlighted, there's need for deep reflection on how these things could indeed impact on the culture that hitherto exists within this facility. And it is on that premise I raised some observations. But I'm very happy over the progress, over having data biology coming to work with us. I do hope that the countries that will be involved with the use of data biology will have Nigeria on that. I'm not sure which facility, but we should have one. Not to say that's the decision of the country leads. But yeah, overall, it's been great. Thank you.
Thank you, Abdullahi. Let me also ask Dr. Wondimu to respond to what we have seen today. Wondimu?
Thank you, Prof. I would like to appreciate Luke for the nice presentation. I think this is what we have missed so far. I think this, if we are work on this, it's contribute a lot for the quality of care and also for innovation, because you know, most of the time you miss data biology, and then linking with the service provision and then quality of care, including to reduce the medical error. So I think this is a great opportunity for us, and then through process we will improve it, and then I think it's great for us. Yeah, thank you.
Thank you, Dr. Mondimu. Let me go to Dean Bernard in Zimbabwe. Dean.
Hello.
Please go ahead, Dean.
Yes, I think this is excellent work and the progress is well. I would like to thank the presenters for a nice presentation. That's all I can say for today.
Thank you. Thank you. Then I'll go to Dr. Reginald. Dr. Reginald?
Yes, thank you very much, Luke, for this nice presentation. There's a lot to learn. And I think as we progress, we can see the different entry points for different countries. And I think here in Kenya, we can do a lot of work with you. So thank you very much, Luke.
Thank you. And then I think, Putu, you wanted to say something.
Oh, no problem, Miriam.
Ah, okay. Perhaps also would like to invite Charles. Charles, good to see you here. You know, we're always missing your voice here on VODAN. So like to hear your response too.
No, I think it's a great setup that the data biology has. Oh, apologies. Hello, everyone. I'm Charles. I know it's been a while since I've been around, but back to data biology, I think it's a great product, especially when it comes to just facilities and hospitals having a better view and analysis of their data, whether it's cost per patient or staff to patient ratios. My question to you would be, what would be the implementation cost for and timelines for implementing that setup that you've shown us for a clinic? So let's say, for example, if you had a clinic today and you were to implement it, how long would it take you to have the system up and running? And what would be, let's say, an average cost? Because at the end of the day, for majority of the clinics, you would have sustainability issues when it comes to pricing. So how much would it cost, let's say, a basic facility to run your system for, or at least use your platform for around a year, for example, 12 months?
Thank you, Charles. And that issue of sustainability has also come up and discussed. And for now, we are working completely on in-kind collaboration. Yep. And we have discussed also the, there was another absolute that the sustainability has to be completely based on the reality that we are working in our VODAN Africa and Asia context. So we discussed that. Thanks, Charles. I'm just taking a little bit of a round. I know that deeper issues to go back into, but just to hear a little bit what people have to say. Let me also ask Samson and Getu for a response.
Hello, Prof. This is Getu. Yeah, I would like to appreciate the presentation by data biology team. It was very impressive, and it has really a lot of applications that we need to incorporate in our product. However, I have one simple question. As our holy grail, as you mentioned it, Professor, is to contain the data locally and to have minimal viable product. So how feasible is data biology for local installation? I mean, I can see a lot of applications, for example, Jupyter R and other. I have just raised this question because I have seen a lot of applications. Thank you.
Luke, do you want to respond to that question?
Sorry, let me unmute. Yeah, so the so I think the question was, how do you install the various applications for the various different use cases, right? So the way, I'll give the simple answer, the way data biology works is all those applications, no matter what they might be, it could be a new script that you've just written or something more established, lots of open source tooling like Jupyter. They're containerized using Docker. And so at the point of analysis, that application, that tool, that program, whatever it might be, is deployed along with the data at the chosen compute location. So if each clinic has their own compute choice, whatever that might be, the application is deployed along with the data that runs. It might be an interactive tool, or it might be something that just runs for a set amount of time, and then the results are returned to the chosen location. So that's the process at a high level. In terms of what different applications can be added, the answer is basically anything and everything. So developers can add whatever script or program they wish. The only restriction I would see would potentially be licensing information if a given tool had a certain license that restricted it to use. But otherwise, there are no restrictions in terms of what's possible there.
Thank you, Luke. So it follows the data visiting architecture completely. I saw that Dr. Kebede from Liberia raised his hand. Doctor, please feel welcome to speak. You're still on mute, sir.
Hello?
We can hear you.
Okay, good. Thank you. Thank you for having me today. So I would like to thank Luke for a nice presentation. So my question is, we do have a picture archival and communication system in our imaging department. So we can archive, compute, and analyze data. So how are we going to link, data biology to PACS or radiology information systems? I'm working in an institution where we are doing research on Ebola survivors. So we can send images with confidentiality to remote centers. So how are we going to link this PACS to data biology?
So, sorry, Miriam. Yeah, the general, it's a little hard to say without knowing the specifics of that PACS system, but generally the way that it would work is the images themselves remain in the PACS system on their original storage. The registration, that sort of that first stage in data biology, just registers the location wherever they may be stored, the address for each image, let's say. And then the data that appears in the search in data biology is just the fields, the criteria by which you might want to build a cohort or select those images. It is only at the point of your chosen analysis where those images would then potentially be transferred, and at that point only ever to the compute location that you had chosen. So the images don't go anywhere, but our default operating model is to let the data reside at its original location. No kind of no centralization to some remote storage, because it's an important point that you're raising for confidential data, and to make sure that everyone has complete ownership over their data. It should remain in the same original location, and then each clinic should have complete control over where it gets sent for their analysis. So wherever they choose.
Thank you, Luke, and thank you, Dr. Kebede, for a very important question. We will need to go deeper into this in the coming weeks. Let me continue to make the sort of the tour. Nambobi, you asked a question. Do you want to ask yourself? Nambobi? Otherwise, let me do that. Maybe the internet connection is not so good. Look, the question was, is data biology open source?
So I'm going on and off mute there.
Do you want me to take that?
Sure, yeah.
Yeah, so data biology software is commercial. We're providing it for the MVP on a voluntary basis, benefit in kind basis, but the software as such is IP protected.
So this is one of the issues that we have been discussing, Nambobi, and which relates to the point of Charles, which is the sustainability. And so in the discussions with the VC, Professor Francesca and Dr. Sakinat so far, we have been discussing with Les, Luc and Luis about the importance of the sustainability and the co-creation for us. So also the issue of ownership, which is kind of an absolute for us. So that is also why we have so far worked with a kind of a ballpoint number of 3 clinics, because we obviously don't want to depend on data biology, but there is a kind of a joint interest to explore the possibilities. And this is going to have to be a very critical point in the way we are moving forward. And also needs to be kind of trust, understanding from each side where we are coming from, and why we are having, you know, as VODAN Africa, these absolutes around our principles. Ezekiel, please, do you want to take the floor? What pipeline are you putting in place for the prediction part of the project? Ezekiel, please take the floor.
All right, thank you so much, Professor. I think that's just the question. So I can see that there's prediction in this project. So which pipeline are they putting in place for better prediction?
Do you want to answer that, Luke? Maybe.
Sure. It's a little tricky to answer because the question depends on the data and the disease, the volumes of data. To give perhaps if I give an example of something that we've done recently on a separate project, we were working with some imaging data for dementia patients, and in that project, the way that we ran a prediction pipeline was through an image classification tool. So there was initially some data that we searched on, like the clinical data, I think looking for early patients that potentially had early onset Alzheimer's disease. And then an image analysis pipeline, a machine learning pipeline that had been added by our team, was run against the fMRIs that were linked to those patients. And the end result was that the pipeline analyzed the regions of interest within the fMRIs and generated a risk classification for the patient's risk of Alzheimer's disease. So I know that's a very specific dementia use case and pipeline, but that's the kind of thing that the kind of way that it would work in data biology. As to what pipelines we can add to the system, that is the short answer is anything and everything, basically. If you have a pipeline that you have in mind that you're already using, we absolutely can add that, and it's same as the data you have control over, how you share your pipeline, where you use it, on what data it gets run, all of these components.
Thank you, Luke. And there's another important question of Charles. Charles, do you not want to ask that question? Charles? Charles?
Sorry, my mic is having some issues.
Okay.
Yeah, so my question was more from a data privacy position. So does data biology itself has access to the data in the clinics? So essentially, can you, as Luke, access data down in the clinics? And can your staff do so? Because when you go down to the lower levels, essentially the data itself it's pretty much all of it. It's Professor Miriam went to the clinic on Thursday, was treated for ABMC, and this is the medicine that she got. So, which might not be something people want other people to access outside, not in its full scale anyway, outside the clinic. So would you have that access?
No, so you know, the sort of setup and the governance is yet to be decided, but you know, I think it's quite clear that our intention would be, you know, no one at data biology would have access to that data. It wouldn't be centralized or transported in any way to some kind of data biology location. You know, that is it's an important principle that each clinic would have complete control over their data. So Les, Lewis, and I wouldn't have any visibility or be able to search over the data.
Charles, that also really depends on how we structure the access and control. That's why we have at the moment simplified it very much and no open queries, because open queries kind of depend on opening them up, and then you have exactly that problem that you just described. So it's a very good question. I see that Dr. Kebede has still a question, and also Dr. Bennett. I'm sorry, I'm going over time a little bit, but I just think it's such an important discussion. And I will also want to ask Dr. Van Stam to say something at some point. Kebede, Doctor.
Okay, thank you. Okay, my question is, in Africa, most institutions, they don't have electronic medical recording system. So is it mandatory to have electronic medical EMS or electronic medical recording system to implement data biology? So,
so the answer to that is Mariam. Mariam has the answer to that. Do you want to answer that, Mariam? Or Aliyah?
hello?
Yeah.
Yeah, just I wanted Luke just to answer me on.
Okay.
You know, most of our institutions, especially if we come to my institution, it doesn't have electronic medical recording system. Most data are registered manually. So, is it possible to, you know, that wouldn't be a challenge for us to implement the, you know, data biology?
Dr. Kebede, that work is what the work is that Mariam and Aliyah were showing in the one-stop registration with the machine readable data. So Mariam, are you there, or Aliyah, do you want to answer this? Or Samson?
Well,
Mariam. Mariam, go ahead.
No, it's okay.
No, go ahead. Go ahead.
Okay, so basically what happens, yes, the data is actually collected using paper forms, and but then it's eventually entered into the DHIS2. It's eventually digitized within the DHIS2. But the DHIS2 is for almost all the African countries, it's controlled by the Ministry of Health, and they're the ones that basically get to do different analysis with the data. So what we're currently doing, my team, the template creation team, is basically digitizing those paper forms and basically translating them so that they're the forms are machine actionable, and then will be processed and yeah, basically the whole process is being worked on. Yeah.
Thank you, Mariam. Samson, do you want to add something there?
Okay, Prof. I think Mariam's answer should suffice.
All right. Dr. Kebedes.
Yes, yeah, I got it. So thank you.
Yeah, thank you. Then I go to Dean Burnett.
No, it's okay. I don't have any question.
Okay, okay. Then
Yes,
let me go to Dr. Van Stam.
Yes, good afternoon. Thank you very much. This was very interesting to hear the reports plus seeing this happening. But when we think about the VODAN developments, I think this is a crucial moment to recognize that the cooperation of knowledge institutes and practical institutes in Africa have resulted into contacts with companies and so on. Normally in Africa, it goes the other way around. And I think it's a big accomplishment of all the partners to really have stumbled on some situation that knowledge is leading, and now we are looking into how to implement it. So also I think out of the presentation, I noticed that the issues of the ordinary way of looking at value chains, where to put data and how to process it, is being challenged by by the principles of VODAN, which are very much the principles of the government and the Ministry of Health, and very much the desire of all countries. So I see all these things coming together. So it's a very exciting moment to see that, and also see that the agnostic C to data is also mentioned, which is a very important development. I just wonder if certain data that we see in Africa as data and that somewhere else might not be received as data would also be captured. But those are all very exciting developments which will bring us further in recognizing what the impact is and how to develop knowledge in this field. So I was really encouraged by seeing this development. Thank you very much.
I think we may have lost Miriam there. She'll be trying to rejoin in a moment.
Alia, can you take over?
Yes, sure. I think there is some problem with the internet issue. Professor Francesca. Okay.
Francesca is not there.
Yeah, she's not here. So, is there any question?
There is question from Busite Alia in the chat box.
Okay. Okay, Joseph says, in case of a clinic 1 working on a project from the clinic 2, what are the limitations of clinic 1 over the data? Can they query the portion submitted, or it only clinic 2 with the rest of the privilege? Mm-hmm. So, Luke, can you answer to this question, please?
Yeah, absolutely. That's a very good question. I'm afraid it's one of these ones where it depends on the specific scenario. Basically, Clinic 2 could choose to present in their shared project any range from the full set of a given data set to perhaps just a subset, either reduced in, let's say, number of records, or perhaps they don't share certain fields, maybe identifiable information or something like that. So they can share a portion of their data set in a separate project. They don't have to share the entirety. After that, it's kind of hard for me to say because it depends on exactly what Clinic 2 wants to share, because ultimately it's up to them. And then what clinic 1 is able to do depends on the access controls that are put around that. So for example, clinic 2 might say, clinic 1, you're welcome to look at this data in this project, but any derived results from the analysis of that data, we still want to go back to our storage, which of course would be a reasonable scenario that we could set up. And so clinic 2 would ultimately, of course, retain control over their data. But it, like I say, it depends on what everyone wants out of that scenario. Hopefully that is at least a little helpful.
Yeah, Luke, sorry, just to interject. The purpose of the MVP and the pilot clinics is to map out what these discrete workflows and process flows and data flows may be, to do those scenarios and permutations, to confirm what the scope will be that will provide the data stewardship controls that are required.
Great, thank you for the answer, Les and Luke. Joseph, does this answer for you, to your question?
Yeah, I get it clearly now, because it was being kind of confusing, whereby two people have to query the same data, yet each clinic has a designated storage. So, but now I get that certain questions should be queried from a certain agent. Now it so happens that only clinic 2 has the overall privileges over the data.
Okay.
Sorry, if there was a question now, maybe my connection's breaking up, but I didn't quite hear the end of that.
Yeah, I think something with the connection. Joseph, can you repeat the last sentence, because I think there was some internet issue on the line.
I was saying that initially it was have to do with a certain project. And now when it comes to querying, it was being critical. Who should do the querying? Okay. So, but later, according to the explanation of Mr. Molson, it was like, in most cases, and actually depending on the kind of understanding, it is clinic 2 that has more privileges over the data. Only that now that clinic 2 is only, rather clinic 1 is only coming in to give some help somewhere somehow, or submitting a certain portion of data, so they can create an understanding which data is dealt with, which portion, as per the submission levels.
Mm-hmm. Yeah, absolutely.
Okay, great. Is there any more question to Luke or to?
Yeah. Okay, thank you, Alia. This is wonderful. Just one question. What's the country's experience on implementing data biology? What the challenge? Maybe if we share some experience and challenge, that would be good for us. Thank you. Over.
Okay. So, Luke, if you can share the experiences.
Yes, let me try to sort of answer that question. Data biology is a virtualized software environment. So, where it resides by way of a country implementation is clearly to be decided. But there's no particular technology lead times for doing that.
Yeah.
So, Luke, do you have something to add?
Just to say, yeah, exactly what Les says. Where the sort of the core machines that are running the things like the data biology portal, yet to be decided. But from our point of view, that's all very easy and quick to deploy, and agnostic to where that is. Of course, leave that up to VODAN's collective team.
Okay, great then. Thank you. So if there are no more questions, I think we already like heading the end of the meeting. So I would like to thank everyone in this meeting to joining this session, and the guests that are present in this session as well. Thank you, everyone. And I would like to say that the recording of this meeting will be sent as usual during this meeting through all our channels, VODAN channels. So sorry for the Professor Miriam's, so there was something with her internet, so she is sending her apologies for that. And yeah, again, thank you very much for joining, and see you next week. And Les and Luke, thank you again for the excellent presentation and answering the questions arising during the meeting. Yeah.
Thank you. Pleasure. Thank you, everyone.
Bye for now.
Bye.
Thank you. Bye.
Thank you. Bye.
Bye, everyone.